Okay, so I'll do number 40. So how much money should be deposited in an account paying 7.8% interest, compounded monthly, in order to have a balance of 21,000 after 4 years? So it doesn't say continuously, right? So we have to do this using a calculator because I haven't talked about logarithms. So, well, we know the final amount. The final amount should be $21,000. The rate is 7.8%, which would mean 0.078. Well, if it is monthly, how many times should you apply? 12. 12. And what is the period?
4 years.
4 years. What is that? 0.078 over 12, 0.06 something.
0.0065.
0065. So go ahead and we need to find that amount, that is the initial amount, right? So over time, when this happens, I get 21,000, so A naught, the initial amount, would simply be 21,000 divided by 1.0065 raised 48. What do we get?
15,387.
So if I deposited $15,387.14 over a period of 4 years, if that interest is applied each year, or excuse me, each month, I would end up getting 21,000 at the end of 4 years. Does that make sense? So as I said, if it is continuous, then we need logarithms, but we haven't talked about logarithms yet. So we have seen this before, finding the equation of a line tangent to a curve. At a given point. So let's see, which one should we pick? I'll do number 26. That looks fine. First, we've got to know the equation of line. What is the equation of line? Did we take algebra?
It's been a
Huh?
while. I said it's been a while.
It's been a while. There were problems like this in the first homework, maybe the second.
Is it mx plus b?
Y equals mx plus
Oh,
b.
well, yeah, I knew that.
You can't say I knew that after I write this down. So we can use y equals mx plus b, or we could simply do the point slow form y minus y1 is equal to m times x minus x1. Either would work. So the key here is to find the slope. Well, what is the slope? We actually have the point, but we just don't know the slope. What the point is x1, y1, which is 0, 1, right? So we know that. We know that. We don't know the slope. How do we find the slope?
The y2 minus y1 or x2 minus x1.
Well, well, you can do that, but that defeats the purpose of calculus altogether. You're not in an algebra class. This is a calculus class. How do you find the slope at a point?
Point slope form.
Oh, this is the point slope formula.
Take the derivative.
Okay, take the derivative, right? So, want to find the derivative of y and plug in the value of x, which is 0, and that would give us the slope. What is the derivative of e raised 4x minus 2 squared? What should we use? If you watched the video that I posted on Friday, you should know. The moment I said video, he just turned around. Did you watch?
No.
Did you watch? What is the point of me posting the videos if you don't watch? Well, I can't tell you what to do, but I know how to take the derivative. Whatever we have is a function here, and we're squaring that function, so we have to use chain rule. If I treat whatever that is inside as x, what is the derivative of x squared?
2x.
2x. So 2, whatever I have inside is not x, rather it is e raised 4x minus 2. What is the next step?
Distribute.
Distribute.
Am I right or no?
Take the derivative of the inside.
To take the derivative, what was that?
No, the derivative of the e, like the inside, that
The
one.
derivative of the inside. And what is the derivative of the inside? What is the derivative of e raised 4x?
4e, is it 3x?
Like, how do we get that? Well, also in the video, the derivative of e raised ax in general is simply a times e raised ax. What is the derivative of that constant?
0.
0. We don't have to distribute and simplify and do all that stuff. It's unnecessary. So I'll just multiply this term with that term. So I have 8 e raised 4x times e raised 4x minus 2. Plug in 0. Well, if x is 0, e raised 4 times 0 is 0. What is e raised 0? 1. 8 times 1, we have 8. E raised 4 times 0 is 0. E raised 0 is 1. 1 minus 2 is negative 1, and 8 times negative 1 is negative 8. Good. So we have the slope now, and we have the point. Y minus y1 equals m, which is negative 8, multiplied by x minus x1 and x minus 0. Yes? You can leave it as is, or you can write it in slope-intercept form. So y minus 1 would be equal to distribute that negative 8, negative 8x. Negative 8 times 0 is just 0, so I'm not going to put that in there. Move the 1 to the other side, we have negative 8x plus 1. Good? And that is the line that is tangent to the function at the point 0, 1. Are we clear? Can I erase?
So we took the derivative and then put it in the point slope formula as m.
To get m. We took the derivative, we plugged in x1 equals 0 in the derivative to get m, which is negative m. We want to find the second derivative of, well, simpler than that. They have a 2x, so I'll just use 2x. It's problem 33. So how would we go about doing this? First, we've got to find the first derivative. What rule should we use? What is u? 2x plus 1. V is e raised 3x. And what does the product rule state? U v prime plus v u prime. U is 2x plus 1 and v is e raised 3x. And what is the derivative of u?
2.
You get 2. What is the derivative of v?
3x e 3x.
3e 3x. All we have to do is take the ones that we found and plug it in that formula. So u is 2x plus 1. V prime, 3e raised 3x. V e raised 3x. And u prime is 2. Could we simplify this?
Yes.
Yes. We have e raised 3x in common. Anytime you want to find the second derivative, simplify the first derivative before you go further.
What is that? Why would it be e or 3e raised 2x?
Because that's the rule. So e raised 3x, distribute the 3, you get 6x plus 3 plus 2, right? So I'm pulling the e raised 3x out. 3 times 2x is 6x. 3 times 1 is 3. 2. Good? No?
Wait, so you went from, I don't understand how you simplified that. So you went from 3e 3x plus e 3x, and then how did you distribute that into that number?
Okay, let me not skip that step. What would we get if I pull e raised 3x out?
3x. 2x plus 1. 2x. 3x?
3x?
No, 3.
Okay, if I pull e raised 3x out of the first term, what would I have? Just 3.
3 times 2x plus 1.
3 times 2x plus 1. If you pull e raised 3x out of the second term, what would we get? 2. Now I'm going to distribute the 3 and then simplify. 3 times 2x is
Oh.
6x. 3 times 1 is 3. Then plus 2. And that's what I wrote earlier, but I should not have skipped that step. Six x plus 5. Yes?
Mm-hmm.
Now, how do we find the second derivative? Take this, repeat the process again. So we'll give you about a couple of minutes. Let's see if we can get it right. So we know the first derivative is e raised 3x times 6x plus 5. That's what we found. So to find the second derivative, we simply call one of the two as u, the other as v. Does it matter which is u and which is v? No. So I'm going to call u to be e raised 3x. And v would be 6x plus 5. What is the derivative of e raised 3x?
3x e 3x.
3 e raised 3x.
Oh, yeah.
Okay. What is the derivative of 6x plus 5?
6.
6. Well, guys, take those values, plug it in the formula. U, v prime is 6. V, u prime is 3 e raised 3x. We're going to do the same thing that we did with the first derivative. What is common between this term and that term?
3e 3x.
Okay. I mean, there is a 6 there, which has 3.
Yeah, you can divide by 6.
So I could simply pull 3 e raised 3x out. So I took e raised 3x out. I took a 3 out. So what would I leave behind in the first term? 2. 3 e raised 3x comes out. What do I leave behind in the second term?
6x plus 5.
So we would have 3 e raised 3x times 6x. 2 plus 5 is Good? Okay, what was your question?
So I was wondering, if because the derivative of e to the 3x was the same as in the first problem, if we were going to just follow the same steps in taking out the e to the 3x. I didn't know you could take the 3 from the 6 in the first term, so I only took out e to the 3x.
That's fine.
And I ended up with e to 3x times 6x was 14, but I don't know how I
It won't be 14 now. It'd be e raised to x, and then you'd have 18x plus 21.
Okay.
That's what you would have.
Could you explain how you got 2 there again?
6 is 2 times 3,
Yes.
right? So if I pull 3 e raised 3x out, what would I leave behind?
You just divide it.
Good. So we did minimum, maximum, all of that stuff in the second chapter. So here is a problem that's asking about maximum revenue. So the demand function for a product is modeled by that expression. You can't say it. It is 7 to 3 e raised negative 0.0000025x. So p is the price function. Can I erase this? The price function is a function of x. What is x? X is the number of units that you sell, or the number of units that are on demand, and p is simply the price function. Going back to chapter 2, how did we find the maximum or a minimum of a function? What is the first step? Finding the derivative. So what is the derivative of the price function? 7 to 3 is a constant, so I'm just going to keep that as is. And take the derivative of e raised negative 0.0000025x. And what is the derivative?
negative 0.00025x e raised to negative 0.00025x.
So we want to find the maximum. How do we find the maximum? That's what it's wanting to know. Well, how do we find the critical value?
Make it equal to 0.
Make this equal to 0. So 7 to 3 multiplied by negative 0.00025 e raised negative 0.0000025x equal to 0. Right? And if I divide by the constant on both sides, I'll have e raised negative 0.0000025x equals 0. Well, what value would give us 0? If x is 0. If x is 0, e raised negative 0.00025 would be 1. Right? 0 multiplied by that, e raised 0. E raised 0 is 1. 1 cannot equal 0. For what value would that equation be true? For what value of x?
1?
Huh?
1?
1. It can only be 0 when
Infinity.
x is equal to infinity,
Um.
because it is a decay function. So what is happening here? Got to go back to the question. So this is the price function. We took the derivative of the price function. What does the question want to know? What price will yield a maximum revenue? Who's a business major here? Okay. What is the difference between price and revenue?
Revenue is how much you make.
Revenue is what?
Revenue is how much you make.
Yes. How is it related to price?
Price is how much you charge them to make the money.
The higher your price goes up, the less quantity demanded, so you don't make as much revenue.
Pretty much what the patent is.
The revenue is after everything's been taken out, so all of
Well, yes, all of those are correct answers, but as a formula, how is revenue related to price or vice versa?
well, once you have your price, then you're gonna have to take out how much it costs to make it, and then multiply by however many you sell.
So, revenue is the number of units multiplied by the price, right? If I have a taco that is sold for $2, and if I got a revenue of $20, how many tacos did I sell? 10. How did I get that? 2 times 10. So, most students, the moment we start with price, would immediately take the derivative, set it equal to 0, come to this step, and we know that an exponential function can only become 0 if x is equal to infinity, if it is a decay. So, key thing to note is to understand the difference between revenue and price. Number of units, x, multiplied by the price function, x, q of x, I'm sorry. We don't need the derivative though. Can I erase? So we want to find the derivative of the revenue to determine maximum revenue. And here, this would be u, right? That would be v, because both of them are functions of x. What rule should we use? Chain rule.
No, product rule.
Product rule. What's up with you and chains? Yes?
Yes.
What is u prime?
Yes. U73.
273. What is the derivative of u? I mean, x? 1. V prime is the derivative of the price function, right? We already found that, so it's that number, or that function. Let's go ahead and multiply 73 with negative 0.00025.
Negative 0.0018.
Now we can use product rule, which is u, v prime, plus v, u prime. So the original price function that's given in the problem is 73 times that messy expression. So what we need is the derivative of the revenue, not the price, which is why I demonstrated that, because that's the most common mistake that I've seen students make. So r prime of x would be u multiplied by v prime v multiplied by u prime. What is u prime? It's just 1. U, v prime, is passed down. V, u prime, v is the original price function, multiplied by u prime, which is 1. How do we find the critical value, which will tell us if we have a maximum or minimum? What did we do with the price function?
So it's 0.
We set it equal to 0. Same thing. Can I erase this?
Yeah.
So we set the revenue function equal to 0 and we solve for x. So we have negative 0.0018x. Those two multiply. E raised negative 0.000025x. Yes?
Yes.
Move that term to the other side. this term and that term are one and the same, correct?
Yes.
On either side of the equal sign. So I can simply get rid of that. Which will simply mean negative 0.0018x is equal to negative 73. The negatives will go away. You have 73 divided by 0.0018, and what is that? $400.
Well, what's the big number? 40,555, is that right?
Yeah, sounds right. That's the mistake. Just looking at the formula. 40,555. Exactly. 0.55.
Yeah.
So, oh, that's the number. Yeah. So, in part A, they want to know the price that would yield a maximum revenue. I know the maximum revenue happens at the X, right? So how do I find the corresponding price? So if I sold this many items, I'm going to get maximum revenue, right?
Right.
So what should the price be?
P over X. Or no, PX.
Can I erase this? It's given in the problem, the price function, right? Which is
Would you plug that number in for X?
would I?
Yes.
Yes. So I know the revenue is maximized at that value, right? So if the revenue is maximized at that value of X, the same value of X when plugged in is going to give me the price that I need to set. Does that make sense? So let's go ahead and plug in doesn't tell me what you get. We are plugging in 40,555.55 for X because I know the maximum revenue happens at that value of X, so what should the price be?
26.48.
How much?
$26.48.
$26.48. Right? And they want to know, well, what would that maximum revenue be if I set $26.48?
40,555.
No, that's the number of units.
Oh. So we would multiply the price by
40,555. So what is that maximum revenue? The price, which is $26.48, multiplied by
1
the number of units. How much?
$1,074,105.31.
Okay. I'll just put approximately 2 million, because I don't want to write all that. But do you understand the concept behind the problem? Of course, as we talked earlier, we're ignoring a bunch of other things, right? The fixed cost, the inventory cost, this and that. This is like simplifying things, but the point of this problem is to illustrate how we could take derivatives and apply to a simple business problem. Yes.
The numbers given in the equation those are just specific to that problem, right? So that's not like a general formula, that's.
Like, yeah, it's specific to this
Okay.
problem.
Yeah.
But the expression itself, it's generalized. So in a sense, if I replace that by some A, and I replace that by some K, that is a general formula.
How are those determined, the constants, like the 73E and the,
That is a statistical thing.
okay,
Right, so you observe a business and you make decisions based on how your business is performing over the years or past, years, and then you determine that value and that value. Okay, good place to stop. If you have questions, talk to me. If not, I'll see you next time.